All right, we're going to talk about this tutorial today, and we're going to look at the first derivative test, and we're going to use it to analyze graphs and justify our answers both orally and in written form. Okay, and we're going to have another one coming up on how to test out the graphs of the function. So we're going to look at our homework problems for today on page 335, and we're going to look at two of them. The first one is we're going to look at the function f of x right here, x plus 2, that quantity squared, times x minus 1. So we're going to find out where this function is increasing, decreasing, and find the maximum. So we're going to be looking and to analyze this. We're going to use our first derivative. In our step 1, we're going to find our critical points, or critical numbers, depending on what we're looking for. Actually, probably numbers would be better, just to make sure that we get all the values that we need to test, all the intervals that we need to test. So we're going to take this derivative. So I started off, as you can see, by finding the first derivative by using the product rule. We're going to take the derivative of our first function, and we're going to use the chain rule. So 2 times the quantity x plus 2 times the derivative of the inside, which is 1, times x minus 1. And now we're going to take that and add it to the derivative of x minus 1, which is 1 times x plus 2, that quantity squared. From here, we're going to simplify this answer. I notice that I have x plus 2. I'm going to factor that out. When I do that, I have 2 times x minus 1 over plus the other x plus 2. And what we're going to do is simplify that a little bit farther. And we have x plus 2 times 2x minus 2 plus x plus 2. These cancel out. And we're left with our solution x plus 2 times the quantity 3x. So that is f prime. We're going to set that equal to 0 and find our critical numbers. Our critical numbers are going to be at x equaling -1, sorry, not -1, -2 and 0, -2 and 0. So those are our critical numbers. Now our second step is after we find our critical numbers, we're going to now create a sign chart. So we're going to take this and do our sign chart. Take -2 and 0. Our interval is going from -infinity to -2. From -2 to 0, and now it's 0 to infinity. We're going to be testing y prime, or f prime. And what we have is somewhere in this interval, we're going to plug in -3 or -5, anything from -infinity to -2. When we do that, we get a negative times a negative, which gives us a positive value. I'm going to plug in x equaling -1 in here into our derivative right there. And what we have is a positive times a negative, which gives us a negative. And then plug in a value here like x equaling 1, and we know we have a positive answer or a positive sign for that interval. So what we have now is f. We know that if f prime is positive, f should be increasing. If f prime is negative, it will be decreasing. And f prime is positive, it is increasing. Now, from here, we're going to justify our answers, okay? Because we found where the intervals are increasing and decreasing. So we're going to write out this statement. F, like that. F is increasing on the interval. And we'll state our interval. Where is it increasing? It appears from -infinity to -2. And from 0 to infinity. Okay? And now because, why is that? We know that f prime is positive. Okay. So now that we have that, now we're going to find out where f is decreasing. Well, f is decreasing on the interval from -2 to 0. All right, because, all right, hopefully we realize that we did our analysis and we realized that the reason why it is decreasing because we found f prime to be negative. So f prime is negative in an interval. So we're going to put that down, and that is our justification for the increasing values and the decreasing. Now, from here, we also were asked to find where our max and mins are. Well, we can see that f prime changes from positive to negative, so this is a max value. We notice that here we're going to have a min value. Okay, so we're going to plug in these values right here. So if I plug in f of -2 into my original function, I will have to go up to check this out. All right, let's take my original function. Oops, hello. So that is the quantity there. So if I take x plus 2, x minus 1, so we get f equaling x plus 2 squared times x minus 1, that quantity. So we plug in -2 and we get 0. So that's our max. We plug in 0 here. And as we plug in 0, we have 2 squared is 4, and then negatives, so we have -4 as our min. So now let's justify this answer. Well, we realize that we have, all right, f has a max at f of -2 equaling 0, because, why is that? Well, we realize on this interval that f prime changes from positive to negative. All right, so we're going to say because f prime changes, the derivative changes from positive to negative. All right, bad, and a little bit better, and we have it. All right. Also, we find that f has a minimum. So f has a minimum at, where's our value? F of 0 equaling -4. There's our minimum. At this minimum, that occurs because f prime changes from negative to positive. And we have both of our justifications, one for the min, one for the max. And now that is how we justify our answer. You heard me say it orally, but also that's how we write it out, right, in written form. Okay. Well, we can verify this by looking at one of our graphs, if you want to, and you will see that, yes, f is going to be increasing, f is going to be decreasing, and increasing as well. All right, well, let's try another one. One more. All right, so let's go to number 21. What we have for this one is that we have f of x equals x to the 5th minus 5x over 5. Okay? So what we're going to do is, once again, I'm just going to simplify this a little bit. I'm going to write this. I'm going to divide this 1/5 into both x to the 5th over 5. And then we have 5x over 5, which can simplify this to 1/5 times x to the 5th minus x. All right. By doing so, what I can do is find a derivative, because once again, my first step is find the critical numbers or points. All right, so we're going to find our derivative, and what we have is x to the 4th minus 1. We're going to set that equal to 0. Remember, critical values are also where we see undefined values. However, in this case, we don't have any undefined values because our original graph is a polynomial. So, by looking at our critical points, we see that we have horizontal tangents, all right, at right here, so 4th equaling 1, and so we have x equaling positive -1 when we take the 4th root of both sides. So we have that horizontal tangents at both positive and -1. So from here, we're going to do our sign chart. Write this up. -1 to 1. We have our intervals, right here. We have f prime, which is going to, and we're going to test this now. Looking at our first derivative, we're plugging -2 to the 4th. Obviously, it's larger than -1, so it's going to be positive. So it's going to be positive. Plug in 0, we get a negative, and then once again we have a plug in a 2, we get a positive value. So we see that f is going to be increasing because f prime is positive. F is decreasing because f prime is negative. And once again, it's positive again, so it's going to be increasing. From here, we can now notice that we have a maximum value at -1 and a minimum here at 1 again. All right. Well, checking this out, we can find these values for our max and min. F equaling -1. We have plugged that into our original function. And what we have, we can plug it into here. And what we have when we plug in -1 is, oh, I guess we'll look at, actually I'll look at this one. All right, -1 we have, appears to be -1, and then +5, so it'd be 4/5. That's our maximum at 4/5. And our min, when we plug in 1, all right, we plug that in there, and what we have is 1 minus 5, which is -4. So -4/5 is where we min. Now, that is very small, okay? We can justify our answers by writing these out, okay? You can approach it from the same thing, so let's do that. And I also want to look at this one as a graph as well. All right, but we're going to first just write out these justifications. That, so I can see what I'm doing. So first off, f is increasing. We'll start with increasing on the intervals. It appears to be from -infinity, -1 we wrote out, and we go from 1 to infinity. Because, hopefully you know that, because f prime is positive. We found it to be positive on those intervals. So our slopes are all positive, all right, from the original graph. We can then find f is decreasing on the interval. Appears from -1 to 1, because f prime is negative on the interval that we found when we did our sign chart in our analysis. We can go a little bit farther, and we found out that we have f has a max at f of -1 4/5, and that is because, what do we see? We found that f prime, all right, changes from positive to negative. And then we have f has a min. All right, up a little bit. Sorry about that. At f of 1 equaling -4/5. And the reason why for that one, as you can see up here, we are going from f prime changing from negative to positive. Okay, so because f prime changes from negative to positive. Now, why do we do graph analysis? Well, graph analysis, now we just finished the justification, by the way. All right, we wrote those out. Graph analysis, the reason why we do it is so we can see, all right, areas and understand why we have increasing and decreasing intervals and where we have max and mins. Sometimes when we look at a graphing calculator initially, we may not originally see it. So what I would ask you to do is actually take out your graphing calculator and graph the original function. Let's just test this one out. I think it actually is a little bit interesting. Seeing that our max and min are so small, I'm curious to see what this looks like. So I'm going to pause this, and please graph that function, and I'll be back in 1 second. All right, so I have my graphing calculator out here, and I punched in this graph right here, and now I'm going to graph it, as you can see. And what you will hopefully notice is, yes, we have some very, very small values. We can verify now. If I take this, I'm going to cover up some of the information, so I apologize about that, but we already should have that down. But looking at our graph analysis, we can verify now, by looking at this graph, that yes, we can see that the slopes are from this -1 value. Okay? At -1, we see that that is where our maximum will be. Now, according to our graph, we really didn't see that initially. Well, we can see by our graph analysis, in our derivative, we know there is a critical point at -1, and we see that it is in fact increasing, because all the slopes are positive on that interval. We then can also notice that right here, from that -1 to now, we weren't really sure by looking at the graph, but at 1, right here, we do have another horizontal tangent, and actually our slopes are negative, therefore our graph is decreasing at the interval. And finally, our graph is increasing starting at 1 to infinity, and we can once again see that that graph is going in the increasing direction. So our values are going up because our slopes are positive. Okay, our f prime is positive. All right, now we can identify that, all right, by our analysis, and also yes, we can identify that using a graph, and we can use the grapher to find out where our max or mins are, and that's another way of doing it. But we now verified it, we justified it both writtenly, all right, through our analytical methods, and we also can state that orally as I was doing on this tutorial. All right, well that is our problems for today. Okay. Your assignment, once again, is to finish up page 335, 20, 24, 30, 32, and 33. Going through the same process I just demonstrated here, I would like you to justify your answers writtenly. Okay, so identify wherever there's points where it's increased, decreasing, justify your answers by writing out that statement. All right, and do that. Okay, if you have any questions, you can bring up in class or write a comment, and we'll talk to you later.